Hey guys, so this next part of factoring actually is our goal. We are going to be solving by factoring. And this is actually the learning target, so definitely something that you want to get down. One of the things that we've been doing already is that when you solve, you want to first set the equation equal to 0. Then we're going to factor. Okay, so we're working on this first step. So looking at our problem that we have here, it's definitely not equal to 0. So what we're going to do is subtract 3x to move it over to the other side. Now what that will do is get a 0 on the right side. Now on the left side, you can see that there's going to be 3 terms, and they're not like terms. This one has an x cubed, then x squared, and then this is really x to the first. So if we bring those down in that order, through 2x cubed minus 5x squared minus 3x, now we have on the left side a polynomial that we're going to factor. So there's our second part of our first step. So this has 3 terms, so you might be thinking x box, but first you're always supposed to look for a GCF. So there's an x that these all have. So if you take out that x, you have this. Still equal to 0. You can keep bringing that down. Now that x is done on the outside, but this 2x squared minus 5x minus 3, we can actually keep going. And with that, we're actually going to do our x box. So a times c is going to be 2 times negative 3, so that's a negative 6. B is negative 5. Now this is one of my favorite problems because there could be a couple of numbers that you're thinking about that might work. So first off, the only 2 types of numbers that multiply to be a negative are a positive and a negative. That'll help you out a lot. Now you want it to add up to be negative. So the bigger number has to be negative. So a negative 6 and a positive 1 are going to work here. So this GCF, remember how I told you to circle and bring it down? That might help. Bring down the first and the last term. And then our 2 numbers that go in the middle get an x. So plus 1x minus 6x. And then from here, we're going to do our grouping. So I'm going to divide it up and take an x out of the first group. So 2x plus 1. And they're both negative in the second group. So I'm going to try taking out a negative 3. And that'll give me a positive 2x plus 1. Because negative 3 divided by negative 3 is positive 1. And at this point, I know that my answer is right because I have 2 of the same parentheses. So one of the parentheses is going to be the GCFs that we see out front. And the other one is going to be the 2 parentheses that were the same. Don't forget your x, right? And that was factoring. We're kind of used to that by now. Okay, but the new part is this step number 2. Set each factor equal to 0 and solve. So this, and this are each factors. So what you do is you set each of them equal to 0. So x equal to 0, x minus 3 equal to 0, and 2x plus 1 set equal to 0. Now the interesting is that first one's already done. That's one of our answers. Oh, the other one, we're going to add 3, and you get x equals 3. And our last one, you're going to subtract 1, so 2x equals negative 1, and divide by 2, so x equals negative a half. And that's solving. Had 3 answers, and it was an exponent of 3. That's actually going to happen each time. Our next example is actually pretty quick. This is a difference of perfect squares, so we can jump straight to that. It's already set equal to 0, so this is good. So x plus 9 and x minus 9 is how this one works, because x times x is x squared, and 9 times 9 is 81. So it's factored. Now you set each of these pieces, x minus 9 equals 0. Set them both equal to 0 and solve. So we had to subtract 9 on both sides here. So x equals negative 9. And add 9 on both sides here. So x equals 9. And that one's solved. That one's pretty quick. The first one we had to do a GCF first and then x box. This one didn't have a GCF. It went straight to difference of perfect squares. So next we have that swap technique, which was sort of interesting here because you had to change x to the 4th to x squared because you're letting x squared be a. Minus 5a plus 4 equals 0. Again, it's equal to 0, so that's good. quick x box we'll see, have to multiply to be 4, add up to be -5. So -4 and -1 should work there. So a squared and 4 come down. Minus 4a and minus 1a will go in the middle. So we're going to group this. The first group, an a comes out. And in the second group, I want to get a positive a to match. So I'm going to take out a -1, so I get a positive a. And then 4 divided by -1 is -4. My parentheses do match, so this is good. I'm going to write my answers together. So a minus 1 and a minus 4. Don't forget, we did a swap, which means that we have to actually put our x squared back in. And when that happens, each one of these is actually a difference of perfect squares. Difference of perfect squares. So the first one's going to be x plus 1 and x minus 1. The next one's going to be x plus 2 and x minus 2. So that is completely factored, and that's what we've done so far. But now, step 2 would be to take each of these and set them equal to 0. So there's that one equal to 0. There's going to be 4 of them in total. And when you subtract 1 on both sides here, you get -1. When you add 1 on both sides there, you get 1. Subtract 2 on both sides there, you're going to get -2. And add 2 on both sides there, you're going to get +2. So really, there are 4 answers to this one, and it had a degree 4. So whatever the degree is how many answers it has. Now the graph on the right actually is pretty cool because it shows you at -2, -1, 1, and 2. Those are all of our answers, and that's when the function would equal 0. So that's another way of looking at this. You can look at it graphically. All right, and for one more here, it says solve the following. This one is a mop technique. Don't forget that that goes to a binomial times a trinomial. So binomial, trinomial. A would be 2x, because 2 times 2 times 2 is 8, and x times x times x is x cubed. B is 3, because 3 times 3 times 3 is 27. So this is 2x and 3, because the first two are a and b. Then it goes a squared, ab, and b squared. So a squared is really going to be 2x squared, 2x times 2x, which is 4x squared. ab is 2x times 3, which is 6x. And b squared is 3 squared, so that's 9. And don't forget, this whole thing is called mop because we're going to match the sign, opposite of the sign, and the last one's positive. All right, so this thing is factored, and if you wanted to, you can check this with the Xbox, but Xbox does not work here. And it really, generally it won't with Xbox, or sorry, with when you're doing the mop technique, generally that quadratic won't work. So take the first parenthesis, set it equal to 0, and you can simply add 3. So you have 2x equals 3, and divide by 2. So x equals 3 halves. And I would circle that. You've got one of the answers. Now don't forget there are 3. So with this second half, though, since it doesn't factor, you have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So as a quick review of that, negative 6 plus or minus the square root of 6 squared minus 4 times 9 all over 2 times 4. All right, so you're going to get a number inside this radical. It's actually going to be kind of big, in all over 8. So let's see here, get my calculator out. 36 minus 4 times 9 is negative 108. So normally in like an Algebra 1 class, you'd be like, oh, can't have square root of a negative, but we can. Remember how we brought this over? Take the negative out as an I, and you can break this down then. So I believe 9 times 12 is 108. Those break up to 3, 3, 3, and 4. Bring down those 3's. So what that means is you got a pair of 3's and a pair of 2's. So a 3 and a 2 go on the outside is 6 So I already have a negative 6 plus or minus 6i. There's a leftover of a 3, so that stays in, all over 8. And we can simplify this once more because 6, 6, and 8 all have something in common. Divide them each by 2, and you have negative 3 plus or minus 3i root 3. Remember, don't change the root, all over 4. Technically, remember, you could split that up to the plus or minus case. So there are 2 answers there, 1 answer here. So with those 3 together, that matches our 3 as an exponent. So this problem is done. If you'd like one to try, here's another one for you to try. It's a little bit simpler with less numbers, but that's it. Go ahead and give that a shot, and you will see some of these notes online for you. And you feel free to pause the video or try it again. And good luck.